Hey guys, I hope you had a good weekend. We're going to continue with our formulas and equations from last week. So the objective for today is going to be calculating percent yield. The percent yield formula is very similar to the formula that we use for percent comp, where you have something over something else times 100, and then you'll get your percent. So a yield, remember, a yield is like what is produced or what you get. So it'd be adding two things, and then whatever you get out of that reaction would be your yield. And then we have to bring in this formula that we used last week, our gram to gram conversions, because they're gonna help us solve these problems. So if you don't already have your foldable out, and I would write this down at the top of your notes, I would title the page percent yield, write down the percent yield formula, and then also write down that you're gonna need your grams to grams conversion. And you can pause this and continue on when you're done writing, but I'm gonna go ahead and continue. So there's this acronym that you can use to remember the order. It's Angry Tigers P. So the angry, the A is going to be stand for actual, the tigers, theoretical, and the P for percent yield. And it's just so you can remember the formula, like what goes on top of what. And I'm sure you can come up with your own, like if you know what ATP is, like that's an easy way to figure that out too. But it's just actual over theoretical times 100 to make it a percent. So actual is going to be like what comes out, and theoretical will be what you predicted, like what you expected to happen. And then what you do is you get the percent yield, and that's going to be what actually happened over what you predicted happening, and that's going to be your percent yield. That's going to be like how accurate you were in your prediction. Okay, so I'm going to give you a real life example. So let's say you're making cookies. You decide to make 5 dozen cookies, and we know that a dozen is 12. So you're trying to make 5 times 12, which would be 60 cookies. The phone rings, you forget all about the cookies, and then 12 cookies burn. So you have to throw them out. Something that could totally happen, especially somebody like me. I'm constantly distracted. So the rest of the cookies are okay. So what's your percent yield of edible cookies? So theoretically, 5 times 12 is 60. So we thought we were going to get 60 cookies out of this batch that we were making. We burned 12, so that left us with only 48 to eat, which is still a lot of cookies. So what you would do is you would use Angry Tigers P or ATP. So actual over theoretical, which you predicted, times 100 to make it a percentage. And you should get 80%, which is not bad. And notice over here that the cookies canceled out, that unit cancels out because we were talking about cookies over cookies. So that way you're just left with your percentage sign. So all units will cancel out except for the percent with this formula. So now let's go ahead and apply this to chemistry. So you'll be given some kind of equation to reactants, yield a product. Remember that this little arrow means yield, it just means makes. The question, what I want you to start doing, because we've been using all these formulas and we've been introducing all this new vocabulary. So I would like you to start like writing down what you're looking for. We're looking for percent yield. That way you know what formula to use and what process to use. And it's asking for the formula of, for the percent yield of CO. So this is gonna be like our wanted. We wanna know what's the percent of CO, and then, you know, like circle it in your equation. That way you can get really familiar with it, know what it's asking you. When 30 grams of O2 are produced. So it's going to get kind of confusing because now you see two numbers, and I've told you in the past that whenever it gives you a number, that's probably your given. But if you keep reading, it says the actual yield is 40 grams of CO. So this gave you your actual yield. So somewhere in your notes, I would write that actual equals this. That way you know that that's your A. So your wanted, this is going to be your theoretical that you're looking for to plug into the formula. See how it gets kind of confusing? So you really need to keep track of these numbers and know what it's asking you for. So we're going to go ahead and work this out. Your first step is to solve for the theoretical yield of CO. So you're going to use this gram to gram conversion. So notice in the equation, they gave us grams of O2. That has nothing to do with CO. So that's why we have to bring in this formula, this grams given formula, because if you're given grams, you can get grams of something completely different. So this is going to be a really useful tool. The formula is up here in the corner. So, and like I said, guys, you can pause this at any time. If I'm going too fast, pause it, rewind, process the information. But if you already have mastered the gram to gram conversion, you're going to be fine. So our first step is to start with the given, and we already identified in the last slide what the given was, which was the 30 grams of O2. So you would just write it down, just like we've been practicing. That's your first step, write it down. So then we're going to move on to our 1 mole given over grams given. Plug that in. And remember that this grams given is going to come with a separate formula off to the side for molar mass. And we did 2 because there's 2 oxygen, and 16 because we looked this up in our periodic table. I know some of you are like, this is repetitive, but just for those of you that are still confused. So then we will move on to mole over mole, and we want mole wanted over mole given. Remember, this is a ratio that we get directly from the balanced equation. So these numbers 2 over 1 came from the balanced equation. And if you already have your wanted and given written down, it just makes it so much easier. Just do that at the beginning, guys. So we want CO, and we were given O2. And it just makes it easier when you're filling this in, because look at all these words: wanted, given, given, wanted. It just makes it so much easier to remember what goes where. And then our last step, oh, and I'm sorry, let me go back a second. So these numbers here, they came from the equation, they came from the coefficient. So don't forget, they're coming from the numbers in front. If nothing's there, you imagine there's a 1. And that's what we plugged in down here. So don't forget that. Our last step is going to be our grams wanted over 1 mole wanted. So again, this 1 mole, it's like that in the formula. Don't make up your own number. Don't plug in something else. Like it says 1, just put a 1 there. And with this grams, remember grams are always molar mass. So off to the side, you have to do the whole steps where you list your elements, count them, and multiply by the mass that you find in the periodic table. So we added those all up, and they ended up being 28, which is why we got this number. So now what we're ready to do is we're ready to cancel out all these units. Grams O2 cancels out grams O2. Moles O2 cancels out this moles O2 down here. Mole CO cancels out this mole CO, and we're ended up with grams of CO, which is what we wanted. We want grams of CO. So then multiply across, so 30 times 1 times 2 times 28, and then go back and divide. Divided by 32, divided by 1, divided by 1. So the answer there is 52.5 grams of carbon monoxide. And we did all of this work just to get the theoretical yield. So we have to still add one more step, but it's very simple. So now we can use Angry Tigers P, which is actual over theoretical, and we'll get our percent yield. So we're just going to plug in. We already have the actual because it gave it to us in the equation in the first place. So 40 grams of CO over our theoretical, which is 52 grams of CO. I just got that from over here. We solved that in the first half of this solution. And you're going to end up with a decimal. And remember, it's a percent. So there's 2 ways you can change this to a percent. You can either multiply by 100, or you can move the decimal place over 2 times, and it gives you the same result, which is 76%. So this is, if we were doing this in the lab, what I would have you do is I would have you work this out I would give you some kind of reaction that we're going to be conducting. So to have you work that out first in class, have you conduct the experiment, collect your data, and then go back and get your actual over theoretical. So this is how we practice this in a lab setting. Example two, what I would do if I was you is I would pause the video and I would look at my notes and I would try to work this out on your own because I provided the solution on the next slide. So it's the exact same steps you have to follow. So what I would do is I would just stop here, practice it on your own, and check your answers on the next slide. All right, so your assignment is just going to be 4 problems for today. And it's going to be, make sure you look for the one with today's date and it says percent yield practice. I provided you the answers, so you have the answers. What I need to see is your work. So please show your work for me. That way I can give you credit. And it's gonna be 4 problems. They're not super difficult. Make sure that you're writing down your wanteds, your givens, following all the steps. I'm going to be available for tutoring at noon. So if you need help with anything, please let me know. And good luck, guys. Reach out to me if you need anything. Have a happy Monday.